The moon is once again in humanity's sights, not as a final destination, but as a stepping stone for future space exploration. NASA's Artemis program aims to establish a permanent base on the lunar surface, a bold step towards sustainable human presence beyond Earth. This ambitious project serves a larger purpose: to pave the way for human missions to Mars, our next giant leap in space exploration. The lunar base, named Gateway, is envisioned as a spaceport in lunar orbit, acting as a crucial hub for future missions. It will serve as a hub for spacecraft, enabling assembly and refueling for deep space journeys, making long-duration missions more feasible. This approach significantly reduces the complexity and cost of launching missions directly from Earth, making space travel more efficient. The moon offers a unique testing ground for technologies crucial for Mars exploration, providing valuable insights and data. Astronauts can test life support systems, rovers, and other critical technologies, and habitats in a real space environment, albeit a much closer one than Mars, allowing for quicker troubleshooting and adjustments. This lunar proving ground will help identify and address potential problems before sending humans on a years-long journey to the Red Planet, ensuring the safety and success of future Mars missions. The allure of Mars extends beyond NASA. Elon Musk, the visionary behind SpaceX, harbors a grand ambition to make humanity a multi-planetary species. Musk envisions a self-sustaining city on Mars, a backup plan for humanity in the face of existential threats on Earth. SpaceX is developing its Starship, a fully reusable spacecraft designed for interplanetary travel. Musk initially aimed for a crewed mission to Mars by 2026, but that timeline has shifted to 2029. Meanwhile, the United States aims to send astronauts to Mars in the 2030s. Interest in Mars is not limited to the United States. The European Space Agency and Russia's Roscosmos are also actively pursuing Mars exploration. The ESA's ExoMars program focuses on searching for signs of past or present life, while Roscosmos has plans for robotic missions and eventually human exploration. Mars presents numerous challenges for human exploration, not least of which is its thin and unbreathable atmosphere. The planet's atmosphere is so thin that it is less than 1% the density of Earth's atmosphere, making it impossible for humans to breathe without assistance. The Martian atmosphere is composed primarily of carbon dioxide, with only trace amounts of oxygen. This means that any human presence on Mars would need to bring their own supply of oxygen or find a way to produce it on the planet. This lack of breathable air necessitates sophisticated life support systems for any human presence on Mars. These systems must be capable of providing a continuous supply of oxygen, removing carbon dioxide, and maintaining pressure within habitats. The thin Martian atmosphere also offers little protection from harmful radiation from the sun. Without a thick atmosphere to block out this radiation, astronauts would be exposed to higher levels of cosmic and solar radiation. The lack of a substantial magnetic field, like the one that shields Earth, further exacerbates this problem. Mars's weak magnetic field means that it cannot deflect solar wind and cosmic rays effectively. Astronauts on Mars would require robust radiation shielding to mitigate the health risks posed by this radiation exposure. This could include specialized suits, habitat materials, and possibly even underground living quarters. Temperatures on Mars fluctuate wildly, reaching scorching highs during the day and plummeting to frigid lows at night. These extreme temperature variations can be as much as 170 degrees Fahrenheit in a single day. These extreme temperature swings pose significant engineering challenges for habitats and equipment. Engineers must design systems that can maintain a stable internal environment despite the harsh external conditions. Developing systems that can withstand and regulate temperature in such a harsh environment is crucial for human survival. This includes advanced insulation, heating, and cooling systems to ensure that habitats remain livable. To address the challenge of breathable air on Mars, NASA is developing innovative technologies to ensure the survival and success of future missions. One such groundbreaking technology is MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment, which aims to revolutionize how we approach life support on the Red Planet. MOXIE is a small yet powerful device aboard the Perseverance rover, which successfully landed on Mars in February 2021, marking a significant milestone in space exploration. MOXIE's primary mission is to demonstrate the feasibility of producing oxygen directly from the Martian atmosphere, a crucial step for future manned missions. It works by pulling in carbon dioxide, the primary component of the Martian air, and electrochemically separating it into oxygen and carbon monoxide, showcasing a novel approach to resource utilization. The oxygen produced by MOXIE could be used for breathing by astronauts or as rocket propellant for future missions, making it a versatile and essential resource. While MOXIE is a promising step forward, scaling up oxygen production to support a human colony will require much larger and more efficient systems capable of sustaining long-term habitation. Future missions will need to develop and deploy these advanced systems to support a sustainable and long-term human presence on the red planet, paving the way for Mars